Welcome back. This is a video on scientific notation. A lot of you may not need to watch this video if you have, you've seen this in math class and lots of other places, I'm sure, but I still want to review it just for those of you that may have been a long time since you've done this. But scientific notation is when you write a big number or a small number and you have a coefficient out front, and this number is between 1 and 10, and you write that number times 10 to the power or to the exponent, okay, of any positive or negative number. Okay, this is very useful in chemistry and in measuring and measurements, because if you have really big numbers or really small numbers and you're trying to write out this really long 0.00000, it just looks much nicer and neater if we put this into scientific notation. Okay, so how do you do this? On the left we have a large number, on the right we have a smaller number. So you go for the large number, you start at the end, okay, and just pretend that you have a decimal there if you want to, okay, and you're going to move the decimal point to give a number between 1 and 10. Okay, some students will accidentally stop, so they'll stop their movement of their decimal place about at the 25. Okay, you have to keep moving it until you get a number between 1 and 10. All right, and then how many ever places you move your decimal place. So here we went 1, 2, 3. Okay, so we would say 2.5, that's the number we made here, between 1 and 10, times 10 to the third power. So how many ever places you move the decimal, that is your number here in red. So here goes with the red there. Okay, if you have a small number, we're going to move our decimal place, okay, to past the 3. Okay, notice that the number is not moved all the way to the end, right? It stops here because you have to have a number between 1 and 10. All right, so you get 3.6. You moved your decimal place twice, so you get times 10 to the negative 2. Okay, if you have to move your decimal to the right, that means you're going to have a negative exponent. If you have to move your decimal to the left, you're going to have a positive exponent. Okay, and how I think of this is, if I have a large number here, okay, that's greater than 1 really, okay, then that number is going to be positive, that exponent, okay, because it's a large number, you got to move your decimal out. Okay, if I have a smaller number here, less than 1, okay, then it's going to be negative. So small numbers, my exponent is negative. That's just one little tip or thing that I think of when I do these. Okay, if you want to do the reverse, okay, and most times you're putting numbers into scientific notation, but if you did want to do it in the reverse, all you got to do is look at this number here. Okay, and if it's positive, that means you got to make a bigger number. So don't go left with your decimal place, go right. And if it's a 2, you move it over 2 places. So it's wanting you to go out to 280. Okay, so this is taking scientific notation back to a standard number. All right, if you have a negative exponent, then you're going to have to make the number smaller. So you're going to go left, and you're going to move it over 2 and pretend there's a 0 there, and you get 0.0280. Okay, notice that I kept all of these numbers. Okay, these are significant. So if you have 4 sig figs here, you have to have 4 sig figs here, and then here I have 3 sig figs, and here I have 3 sig figs. So remember that these 2 leading zeros are not significant, and this 0 is significant because it trails a decimal place. So in that number there, I have 3 sig figs. All right, the diameter of chickenpox virus is 0.000003 meters. Not sure if I said all the zeros or not. Okay, but we want to move the decimal place to give us a number between 1 and 10 and put it in scientific notation. So we're going to go 1, 2, 3, 4, 5, 6, 7. Okay, so we have 3 times 10 to the negative 7. Okay, we have a negative exponent because we moved to the right and it's a small number. Okay, and then we only have one sig fig, so all those zeros there are not significant because they're leading. Okay, so the 3 is the only significant digit, so we have one sig fig. Okay, this is just the exponential part. Okay, and then meters, of course, we have to have our unit. All right, this number here, I actually just randomly wrote it down. Just any number you want to write down and try to, big or small, want to try to convert it to scientific notation. So this is a really large number, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I moved my decimal place 8 times to put it past that 1, so that I have a number between 1 and 10. All right, here I want you to report to 3 sig figs, just because we got a lot of numbers there. Okay, so I'm going to put 1.09. Okay, if you look at that 9 there, there's a 0 next to it, so we would keep it at 9, round it to 9. Okay, and times 10, this is a large number. We moved the decimal to the left, so we moved it 8 times. So if you move your decimal place 8, then your power there is 8. All right, I hope this helps with scientific notation, and I will see you soon. Thanks.